Welcome to a CCC Town Hall, Making Research Data Fair. I'm Christopher Keneally, host of CCC's Velocity of Content podcast series. Last week, the Spanish national government approved a strategy on promoting open science. Spain's Ministry of Science and Innovation said the effort would be implemented over a 4-year period, starting with a budget of $26 million for 2023. One objective is to promote the management of research data using the principles that data should be findable, accessible, interoperable, and reusable. Mandated by funders and governments and implemented at universities and research-intensive organizations worldwide, FAIR data principles, ensuring that data is findable, accessible, interoperable, and reusable, are expected to drive innovation in science in the years ahead. Proponents say FAIR will accelerate machine readability of research and thereby lift discovery to greater heights. My CCC Town Hall panel will share best practices for developing research data that is fair through culture, training, and technology. We will learn how FAIR data saves lives, saves money, and drives confidence in science on 4 continents. And our very special guest, George Strawn, a scholar at the U.S. National Academy of Sciences, Engineering, and Medicine, who served as CIO with the National Science Foundation from 2003 to 2009, joins our roundtable discussion with reflections on a half-century of Internet evolution and the transformative role of FAIR data in the future. Barend Mons in the Netherlands, you are president of the Executive Committee of CODATA, the Committee on Data of the International Council of Science. As a molecular biologist, you are responsible for groundbreaking research on malaria parasites. In 2014, Barend, you became involved with creating the FAIR data principles, and today you are a leading advocate for their adoption and for data stewardship, ensuring the quality of an organization's data assets. So why have you committed yourself to this ambitious effort?
Well, thank you for the question. It's actually enlightened self-interest in a way. If I look back a little bit, if I'm allowed, in 1996, when George was still very active in the internet, early internet, I started something called Scientists for Health and Research for Development, shared, because I saw that we needed a lot of better connections across languages in Africa. But then I really started to apply it for my own genetic research. And in 2005, I published Which Gene Did You Mean? Which contains my most hated statement, I think, why bury it first in narrative and then mine it again? And I was already starting to see the value of machine-readable data, seeing that the amount of data we generate is so large nowadays, which is a lot later, we actually double our amount of information in genetics every 6 to 10 months. So there's no way to work without machines, and that's why I need FAIR data for my own research. But I also became an advocate because I think it can change the face of science and the whole way we do open science fundamentally, which is needed.
Christine Kirkpatrick, you lead the San Diego Supercomputer Center's Research Data Services Division, and you are head of GoFair US. Are data scientists the only ones in the research community who care about FAIR?
Definitely not. And a whole bunch of people are data scientists that wouldn't call themselves that. So data scientist is already a fraught term. But let me start by saying that I think that the answers to many of our societal problems, from climate to human health, you name it, are in data that we already have. And the answers are waiting to be unlocked. This is the reason that I have dedicated so much of my brain space and time to this. A 2016 Bloomberg survey said that 80% of the time that a data scientist spends with data is finding and cleaning data. And that wasn't the first time. Before they called it data science, in data mining, we had the same things in the academic literature, that people who had spent lots of time in school were spending time basically doing a lot of clerical tasks trying to clean up data. And so this is why I spend so much time trying to figure out the connection between the FAIR principles and time to science, making sure that data scientists or anyone working with data can get started quicker and spend more of their brain power on actual analysis. So I really think that anyone who analyzes data or relies on the data analysis, which again is anyone on the planet, should care about this topic.
And Erik Schultes with the Go Fair Foundation in Leiden, the Netherlands. What kind of data do we want to be fair? Are there priorities for certain types of data over others?
Sure. There's a broad spectrum of different kinds of data that we all care about. I think one thing that the FAIR Principles has done a very good job at, when you look at how these 15 one-liners, these FAIR Principles were constructed, it really elevates the idea of metadata to be a first-class citizen along with the data themselves. And so, I think one answer to your question, Chris, is metadata is sort of a non-negotiable for FAIR. Without FAIR metadata, that is machine actionable metadata, your data assets, no matter what they may be, will not be FAINR in any automated way. So metadata is a given. But then after that, we can say, there's certainly a lot of legacy data out there. We've already created huge amounts of digital information. We could say, well, yeah, all of that needs to be fair. But I think more strategically, we would say, well, maybe that data can be made fair at the time where it needs to be accessed again or reused. So that might be one way to kind of prioritize the verification of legacy data. And then looking forward, given that the doubling time for data may be as short as 6 months in some domains, there's an exponential increase in data. The verification in those domains, and let's say in high throughput data environments, could have a huge payoff, because even within a couple of years, you could have the majority of your data in that FAIR format already. So it's really a case-by-case basis. I think one should be very practical in the approach on that. But we have, I think, emerging strategies and guidelines for the prioritization on that.
Francisca Oladipo joining us from Abuja, Nigeria. Welcome. You are Professor of Computer Science and Vice Chancellor at Thomas Adewume University and founder of the Africa University Network. The effort to verify data across Africa was sparked by the COVID-19 pandemic and shaped by lessons learned from Ebola outbreaks. Tell us how those two dramatic healthcare calamities converge in Africa around research data.
Thank you, Chris, for having me. In the case of Ebola, the data collected from the countries that were affected in West Africa, East and Central Africa, they were taken away from Africa. They never returned. And so researchers from Africa and even from the affected countries and the health facilities no longer have access to those data. And even if we're able to find them, we're able to have access to them, they're not reusable, they're not interoperable. In the case of COVID, prior to the founding of our network in Africa, the data from Africa was poorly reported. But now with FAIR, our data has become global. We have a set of principles for researchers in Africa to share their data, for the data to be reusable, to be discoverable by man and machine. We're now able to generate, we're able to curate and hold data in residence. And of course, with FAIR, we've been able to establish data ownership in African countries. And many African countries are no longer anonymous in the sense that we can always tell where the data is, where it was collected, the address of the health facility, for example, or the research institution, and then, of course, where the repository is and how it can be found, the principle for the reusability, for the access, and everything around the principle of the management of the data. So our data now through FAIR are generally discoverable by both men and machines. Algorithms from researchers in China can actually discover data reposited in a small village in Nigeria or Uganda or Tanzania. Thank you.
And Deborah Drucker in Sao Paulo, Brazil, at Embrapa Digital Agriculture, one of the Brazilian Agricultural Research Corporation research centers. You hold a degree in forestry and work closely with GoFair's agriculture and biodiversity networks in Brazil. Welcome, and tell us, how will FAIR data help you advance the Embrapa mission?
So Embrapa mission, in short, is to provide knowledge to help sustainability of agriculture, and this is per se interdisciplinary challenge. And we do need data from different disciplines in agricultural sciences and environmental sciences. And very often we need long-term data to understand the complex processes that are also being affected by climate change. And all of that is needed to provide food, healthy food for everyone. So we do need data to be fair, and we have been working with that even before the concept was generated. So it's very important to have the data well organized and reusable with metadata and everything that the previous speakers already touched on. And it's also sometimes really time-consuming and expensive to collect data in certain places, so it's important to make the most use of it in benefit of society. Thank you.
Thank you. Thank you, Deborah Drucker in Sao Paulo, Brazil. Obrigado. You know, the discussion so far has really sharpened the focus for me on why fair data is fundamental to the future of the internet as a welcoming place for innovation and discovery and research. And I think we can see paths for improvement, and we can begin to understand how fair data will lead to breakthrough interoperability across research domains. It's time to say greetings to George Strawn, a scholar at the U.S. National Academy of Sciences, Engineering, and Medicine. George Strawn served as CIO with the National Science Foundation from 2003 to 2009. And he joins us today in our roundtable discussion with reflections on a half century of internet evolution and the transformative role of fair data in the future. George Strawn, thank you so much for joining us today on the CCC Town Hall.
Glad to be here.
Now, you identify 3 steps in the evolution of computing. The first step came after World War II with the ENIAC and UNIVAC, the first programmable digital computers that were enormous standalone machines. And then came the internetworking era that began in the 1970s when you were starting your own career as a computer scientist at the University of Iowa. What new era in computing will fair data bring?
Well, thank you, Chris. I think that's the right head in the clouds question. As you say, the first wonderful step was computers themselves. The second equally important step has been the internet age of interconnected computers. I think FAIR is ushering in the third phase of information technology, which is interoperable data as well as interconnected computers. And looking back over the past couple decades, I think I can highlight 3 examples that already prove the value of this third phase of FAIR data. The Human Genome Project discovered eventually 20,000 genes or so of the human genome, and all of those gene discoveries were placed in one FAIR database. What if we had had 20,000 independent researchers, each contributing their own data in a non-compatible format, and then somebody had to try to put that data together afterwards? We didn't call it FAIR back then, but that's what it was. The Human Genome Database was a FAIR database that accelerated greatly the conclusion of the Human Genome Project. In a different discipline, although beginning about the same time, astronomers worked to get all telescopes to have standard output metadata, that is FAIR metadata, that in effect allowed all pictures of a given part of the sky to be overlaid, looking for similarities and differences and whatever. This resulted in astronomy being now called the virtual observatory. And according to my understanding, it has revolutionized the science of astronomy by being able to have FAIR from the instrument data. Third and most recent is the solving of the 50-year-old protein folding problem, which is an example of machine learning. And of course, we now know that machine learning is in the news as a Should we worry about futures? Well, perhaps we should, and perhaps that's a discussion for another date. But certainly the benefits are at least as large as the dangers. Barend has pointed out from time to time that FAIR is an overloaded acronym. It can also stand for fully AI-ready data. And in order for the training of machine learning algorithms to occur, the huger the better, databases of data needs to be analyzed to do the training to make the algorithms work. Well, that's what happened with the protein folding problem. People have been working for 50 years on finding a computing way to solve that problem rather than the expensive and time-consuming X-ray crystallography approach. A couple of years ago, it was designated as the science breakthrough of the year and is revolutionizing a proteomic part of biology. If we think of the revolution in proteomics and genomics and in astronomy, these three breakthroughs have happened because of FAIR data, even though we didn't call it FAIR at that time. I'm convinced there are untold additional breakthroughs of those magnitudes that will be available with the progress that my colleagues have just described as we are moving forward to fully implement this third phase of information technology, interoperable data.
Well, George Strawn, thank you for that. And thank you for adding to our definition of FAIR. I love fully AI ready. That seems perfect and brings us right up to date from the internet birth to today, because AI is so much on people's minds. Does FAIR data play a role in developing greater trust in science? I'll let you go first, Christine. So what about that? What about sort of FAIR as a way to help the public feel more confident in research and to trust the science that they're told about?
Absolutely. This is something that we're working on and that's very needed. Several of us on the panel are part of something called the FAIR Digital Object Forum, which is working on what we think will be the next architecture of information for the internet. And if you remember back, those of us who were there when we had our first websites, you had no such thing as a secure connection. You didn't see a lock in your browser. There was no such thing as that. And then over time, we had certificate granting authorities, and people started to look, and they said, I'm not going to put my credit card information in unless I see a lock up there on the top left in the browser. We're going to develop the same things, and we're going to need everyone to learn how to look for whatever the equivalent of the lock will be. But right now, there's a whole bunch of information coming out of AI that's just garbage. I also wanted to highlight another project. It's called FAR. It's Fair and Machine Learning, AI Reproducibility, and AI Readiness. And this is a consortium of people who are looking at the intersection of these two things. If that interests you, it's farr.rcn.org, and we'd love to get your thoughts, especially people who've tuned in and have more to say.
Let me give you one example on the notorious thing that hydroxychloroquine would treat COVID. That was published in the Lancet. So, these language models will just pick it up and tell you it's a good idea. And if you are able to feed them with machine-readable provenance information, they would find out that now about 500 orchids, scientists don't believe this anymore. And there's probably 2 people in the world that still believe it. We won't mention names. So the idea is really that if these large language models, which are potentially powerful, they're just word calculators, of course, they actually could be very important in the future if they cough up scientifically validated information, and they tell you if you only believe a subset of information, even a subset of scientists, in which bubble you are, so that you can also leave that bubble again and say, what if I look at this thing from a totally different perspective? And that is where FAIR will play an enormously important role in the future.
Well, Barend, you talk about provenance and the reliability. And I want to end with Francisca, though, because you've been talking about the importance of including African-born data, I'll call it that, in the global data network. And when we speak about these large language models, questions are raised about whether they are diverse enough in the sources that they probe and whether they sort of reflect biases and so forth. So it sounds to me like you would be also part of really wanting to see fair data, verified data from Africa included in the training that happens for these LLMs. Is that true?
Yes, that's true. That's correct. It's actually part of the goal. We are looking at the globalization of data collected from Africa. And so, yes, it's part of the goal. And we are encouraging researchers who are working in the areas of LLM and those who are working in machine learning AI, who are working generally in a natural language processing, to ensure that they concentrate also on low resource languages, like languages that languages are spoken by millions, but there are very low resources for them, to ensure that at the end of their research, to ensure that not only the data, but all the research artifacts are verified, and then they're discoverable by these language models.
All right. Well, thank you, Francisca. And, British economist and Nobel laureate Ronald Coase once said that if you torture your data long enough, it will tell you anything. Today's CCC Town Hall has taught us the value in treating our data well, because then it will return the favor. I want to thank my guests, Barend Mons, president of the Executive Committee of CODATA, the Committee on Data of the International Council of Science, and with the Go Fair Foundation in Leiden, the Netherlands. Thank you so much, Barend. Also, Christine Kirkpatrick, head of Go Fair US, based in San Diego. Erik Schultes with the Go Fair Foundation in Leiden as well. Francisca Oladipo joining us from Abuja, Nigeria, professor of computer science and vice chancellor at the Thomas Adewume University and founder of the Africa University Network. And Deborah Drucker at Embrapa Digital Agriculture, Sao Paulo. Thank you all very much indeed. Rob Simon of Burst Marketing is our director. Thanks as well to my CCC colleagues, Joanna Murphy-Scott, Amanda Ribeiro, Haley Sund, and Molly Tater. Stay informed on the latest developments in publishing and research by subscribing to CCC's Velocity of Content blog and podcast. CCC's interactive visual report, The State of Scholarly Metadata 2023, is online at stateofmetadata.com. We invite you to have a look, interact with it, and share with us the problems and the challenges that you have around metadata. Again, that's at stateofmetadata.com. I'm Christopher Kenneally for CCC. Thanks for joining us. Goodbye for now.